A very pleasant welcome to Security and Privacy in Cloud. I'm Jay Lavanya, Assistant Professor of CSE Department. So today we're going to discuss on the Unit 4 Cloud Security Design Patterns. Under this, we're going to check the topics on geotagging as well as secure cloud interfaces. So first one, what is the geotagging? While the cloud enables the workloads and data to reside anywhere, the user may be constrained to run their workloads and save their data in certain geographies due to regulatory reasons. This extends beyond trusting the cloud's hardware resource to be free of malware and rootkits. Extensions of trusted compute pools enable associating with hardware at provision time geotags. Intel Trusted Execution Environment, that is TXT, and other machine launch environments facilitate machine such provision time information into the trusted platform module. So, in simple term, I can say the definition as geotagging is a method of embedding location-based information into the data or resources stored and processed in cloud platforms to enhance some data organization. The main important key aspects is that metadata attachment, which adds location information to the files, example photos or records, example like user activity logs, and cloud integration, which automatically managed through some API and services, example AWS or Google Cloud, that supports the location tagging. And the main applications say, if you take regarding the geotagging is that content management, location-based analytics, security and auditing, IoT and smart devices storing location data in the cloud. Next topic is that what are the use cases of geotag? So first is that research freedom, and second government security requirements, and third one is commerce, and fourth one is that NOVA aggregates and availability zones. And last one is that NOVA schedule filter. So these are the common use cases of geotag. But apart from that, we also have some described font regarding this geotag. So first one, research freedom. So companies, may restrict what categories of research are carried out in different geos. For example, if you take stem cell research, discovery research fall into this category. Each government may have different policies around these tracks. Okay, and then second one, the government security requirements. So governments may require that their workloads run and their data is saved only in certain geos. For instance, they may not want either to leave their sovereign territory, with the exceptions being made for embassies and international waters or some aid. Okay. And third is that commerce. So what does mean commerce is that? So retailers for taxation purposes either to avoid or reduce them. Some US states they have higher tax rates than others, or even gain some special tax benefits such as the hosting sites in export only zones, and they may want to restrict or enforce where their workloads and data are stored in the cloud. And retailers they go beyond the brick and mortar store when consumables are digital such as video, audio, images, software books, and more. Banking is another regulated industry, and customer data in some banks, which enjoys greater privileges due to some international agreements. Okay, and what does mean by NOVA aggregates and availability zone is that the partitioning, resource reservation, and fault tolerance benefits that NOVA aggregates and availability zones bring have a lot in common with geotags. However, the main difference is that trusted tags, provision time values and attached to the hardware resource, and repurposing a mission is more easy via the command line with aggregates and availability zones, which does not require mission reboot. But To modify trusted tags, more deliberate action is required. Mission reboot, which ensures no VM or data relocated. That's the reboot audit trial. The geotag, by virtue of being associated with the hardware root of trust, is more valuable with respect to meeting regulatory requirements. Further, the attestation service could be independent of the cloud provider to increase credibility and better meet regulatory requirements. In addition to that, geotags can be verified with about 90% accuracy using some software techniques using the internet protocol address of the device which is being attested. Okay, and OpenStack changes is that they geotagging, what they'll be doing is that they'll be built on some trusted compute pools features which is covered in some trusted computing pools. Okay, and there is another thing in the this Nova aggregates and availability zone. During some computer node provisioning for trust, geotag may also be assigned. These can be some simple strings such as third floor, Expo Center, Hong Kong, or complex such as XML data providing subdomains such as GPS coordinates, postal address, and board or JSON strings, something like that. And in dashboard, they'll be using some flavor extra specs or some volume extra specs. These extra specific specs is like specifications. Field readily supports specifying geo and other asset tag constraints and displaying VM and volume geo asset tag affiliations. The horizontal UI, for instance, and volume list could be extended to display in addition to the current information and trusted and geotags. For instance, it would be logical to add a little trusted seal if a computer trust is, or by extension, a VM running on the same computer node. A country flag would be a good geo indicator. And another that is the object list, which could also contain some geo indicator. And next is that a NOVA schedule filter. So assets or geotag filter should be specified for this kind of filter. This is very similar for today's aggregate and availability filters with the distinction that the data they retrieve from the attestation service may need to be passed. For instance, geotag data may be retrieved as a JSON string or as an XML. In case of XML, the data may be compromised of a global positioning system with GPS coordinates element, a postal address element. The data so retrieved may need to be parsed if the filter requires match on a country or a state and something like that. Okay. We recommend the filter code which takes a policy argument to determine what manner of parsing is required, and extracted data then be used to determine the placement. And filters could also be the a logical uh, or of geos. Okay, the same filter technique or usable by the scheduler for volume placement and live migration of VM. And apart from these 5G's use cases of geotag, there is another like in storage, audit task, and attestation service. So what is meant by storage is that so geotags are readily usable for block storage. Object storage in the context of a switch is a little more involved and shall be covered in the separate blueprint and be addressed in phase 2. So this is chiefly because the functionality that computes the hash code to determine where to place the shift replicas needs to be modified. Okay. Further, the ring balance logic in the event of hardware or the network failures need to be modified. Last but not the least, the shift API for the object put or get command will need to be modified to specify some geo or some asset tag constraint. And next, there is an audit task where audit logs of VM and volume related crude activity could capture some geotags. Uh, so these would serve a well compliance. Further, a periodic audit reports to all the cloud services could also capture the geotags, and cloud asset particulars could also be saved in the databases along with some configuration or information about the patches and upgrades. A sanity check would be that the reported geotags match what is in the database. And next use case is that attestation service. So existing attestation service needs to be upgraded to understand geotag, support an API to retrieve them for registered hardware resources. So the geotag retrieved for hardware resources could be captured at the earliest service or even at the NOVA scheduler to speed some scheduling decisions as long as the uh, cache value is now older. That's some specified time window. You know, the simplest geotag is a string, while more complex variants in XML are JSON strings. So a match policy, what will happen is that, so here it will be going for some, country match or some state country and or city state where you have to format parts a given representation. By means of that, we could able to format some sparse representation which is required to facilitate the match. Okay, so these are the use cases of the geotag. Okay, so this is all about the use cases of a geotag. So next, we will see some of the research freedom example. So here, Intel is driving the effort to realize the geotag in TCP, where the measure launch environments will measure the tags and associated attestations. Service should determine the measured values match registered with list values, confirm that the certificates are authentic or neither expired or revoked. So based on the OpenStack like a dashboard geo filter, it will be scheduled for each and every country like China or US or India or something like that. And where the attestation will be given in terms of OAT and the audit logs will be checked based on the compliance of the monitoring report. And so this is a simple example for the research freedom. Okay. This is a using like geotagging to direct some web annotations on some cloud storage file. Here they have described some simple example for it. I'll just explain the code, so what they have given here. So to perform some web annotation detection on a file storage using some cloud site, we have used some geotagging concept here. So what they have done here is that let's break down. This is actually a Python function, right? It uses some Google Cloud Vision API to perform some web detection. And the first step is that first we are defining a function name called that is web entities include some geo results URI, and it takes a single argument that is Google Cloud Storage URI. And next we are importing the Google Cloud Vision client. So here the importing like needed to which is interact for the Cloud Vision API. And next we are initializing the API client. So here we have to create a client object that allows to call Vision API methods like a web detection of, for that purpose we are going for it. And next one creates an image object and sets the source to the URI provided must be a file in a Google Cloud Storage. And next is that we are using some configuring some web detection to include some geo-based results, meaning it will consider any like location metadata like geotag which is embedded within the image. So if it is true in the sense, it will be automatically like GPS coordinates will be existing data it will be taking. And next is that we are creating the image context. So here we are attacking some web detection params to it, and this tells the API to use who are all the parameters during the processing and performing web detection. Here we are sending the request right to the Vision API to analyze the image using some web detection and considering the geotag due to some context which is set earlier. And here we are processing and printing the result, so which iterates through a list of web entities found by the Vision API. So each entity is something the API identified that may be related to the image, like people or landmark or the objects. So score here is that it's a confidence value, how likely the entity matches the image, and description is a human readable label for that particular entity. And next, suppose in your geotagging, while you are doing some process, if some exception arises in the sense, API returns some error which raises an exception and provides a link to the Google's API error documentation for troubleshoot. So this is an overall by using geotagging, being able to detect the web annotations. Uh, Next topic is that we are going to discuss is about a secure cloud interface. So what is meant by secure cloud interface? It refers to the state, safe interaction between the users, applications, and cloud services, ensuring data integrity and confidentiality authentication while accessing some cloud resources. So what is the security features of cloud interfaces? So first one, authentication and authorization. Second one, encryption and data protection. Third one, API security. And fourth one is that monitoring and threat detection. And last one is that compliance and governance. Now let us see one by one. So first one, authentication and authorization. So it uses OAuth, that is a multi-factor authentication, and single sign-on for secure access, and encryption and an authorization which implements a role-based access control, which we have already discussed in the unit 2. Okay, and you can check out that videos. And encryption and data protection, there is a TLS, a transport layer security, which ensures secure communication between the users and the cloud APIs, and end-to-end encryption, which protects the data during transmission and at rest. Okay, and the next is that API security. So API gateway and rate limiting, which prevents unauthorized or excessive access, and JWT, which is JSON web token, which is used for secure token based authentication, and monitoring and threat detection, which uses SIME, that is security information and event management tools for real-time monitoring, and which implements the anomaly detection to identify the potential security threats. And next one is that compliance and governance, which follows some industry standards like ISO 27001, GDPR, HIPAA, and NIST for cloud security. Logs and audits access to cloud services for some regularity compliance. So apart from that, we can say what are the key components of this cloud interface is then like user interface, usually a web-based dashboard like provided with the Google Cloud Platform like AWS or GCP or Azure, and displays some real-time insights into some security status, incidents, and vulnerabilities. Then allows configuration of access control, firewalls, or encryption, security policies, and API like application programming interface, which enables some programmatic access to security settings and logs, and useful so for automating compliance checks, instant response, and integration with SIGN and SOAR tools, and security service access like access to services like identity and access management, and encryption and key management, and intrusion detection prevention. Okay, and security group, firewall, network access control list, and audit and logging interfaces. So we use logs from services like AWS Cloud Trial, Azure Monitor, or GCP Audit Logs, which tracks the access history, API calls, and configuration changes. And policy management is that like it defines some enforce some security policies, tools like AWS Config or Azure Policy, which helps to ensure compliance with security best practices. And alerting and monitoring is that integration with alerting system for real-time threat detection, example Amazon Guard Duty or Google Security Command Center. Okay, And example interfaces like AWS Security Hub, Azure Security Center, Google Cloud Security Command Center, which we call as SCC, and cloud native sign like Splunk, Palo Alto Prisma, or Datadog Securities. Okay, and benefits is that centralized view of cloud security posture or streamline access and governance, and enhances some threat detection and instant response, and supports automation and the scaling of security. Okay, so all those things comes under uh, key features of the cloud interfaces. So this is the diagram for secure cloud interface. So here you can see like there will be an interconnection to cloud where the public internet and some apps to the mobile user or some dedicated connection we can able to go through it. And so this is like access a firewall or some network policies or threat detection, and we can able to view some security status, manage roles and permission. Here are some external API like anti-federation or WAA for DDoS tag or SSLI. And by using some Python code, like, for developing some IAM client, you can go for some create in Python to monitor the roles and responsibilities. Yes, it will be happening. Okay, so this is all about the secure cloud interface. Next, we will discuss about the secure cloud interface application. Like example use case is that, like, if you're going for some secure banking application, okay, there for interacting with the cloud-based AI fraud detection system, which ensures that the customer data is encrypted. Only authorized employees can access the sensitive transaction, and suspicious activities trigger real-time alerts for investigation. And secure cloud interface application is that uh, secure cloud interface applications is used in some various applications that require some a safe communication, data exchange, and authentication between the cloud services and users or systems. And common applications include is that cloud storage services. So here, like Google Drive or OneDrive in Microsoft or Dropbox, secure access and file sharing. And second one, like cloud API and web services, enterprise collaboration tool, healthcare and finance application, and e-commerce and payment gateway. So on cloud API and web services, AWS API gateway like Azure API management or secure application interactions, and enterprise collaboration tools. So Microsoft 365, Google Workspace, secure document collaboration, and healthcare and finance application like HIPAA, like compliant healthcare portals and banking services, secure data handling, and e-commerce and payment gateway uh, like PayPal, Stripe, Amazon Pay, secure online transactions, and IoT and smart devices, connected home devices, industrial IoT systems, where it's used. So these kind of things are used as an application and secure cloud interface. Next, we will discuss about the secure cloud interface advantages. Enhanced security, a secure implementation implements encryption, authentication, and access control. And scalability and performance here supports a large-scale application with some optimized data exchange. And cost efficiency reduces the infrastructure cost by leveraging secure cloud API. Flexibility and interoperability, which connects the various cloud-based applications seamlessly, and compliance and data protection, which ensures some adhere to the security standards like GDPR or ISO 27001 or HIPAA. Okay, see, so these are the advantages, but if you take the real-time advantage of secure cloud interface, So here it uses some real-time threat detection and alerts. For example, it monitors the cloud resources continuously, like AWS Guard Duty or GCP Security Command Center, which alerts you when some compromised IP accesses your instance, and which triggers alerts or automated responses or quarantine and locks the user. And next is that live visibility into some security posture, which provides a centralized dashboard showing the health and compliance of your cloud environment, and quickly see some misconfigured firewall or unencrypted storage or open ports. And Azure Security Center shows some real-time security score updates as you remediate issues, and instant access management. It enables live control over the users and services, and revoke the permission, rotate keys, or update the policy by means of using IAM access in seconds during some breach. And real-time compliance monitoring is that like AWS config, if you are using the sense which detects a public S3 bucket and auto restricts, which is based on some real-time rules, and automated remediation. So GCP can auto disable a VM if some abnormal traffic is detected by means of some rollback changes or isolate resources and patch the vulnerabilities. Yes, and scalable and always on security is that so 24 bot 7, it will be access and security in the cloud infrastructure. So where we can able to go for some various downtime or manual checks is needed. And so this is the overall advantages of using the secure cloud interfaces. Okay. So next topic is that we will discuss about the drawbacks or the disadvantages of using some secure cloud interfaces. So first one is that complex integration, second one latency issues, third one potential API vulnerabilities, fourth one dependency on cloud providers, and last one data privacy concern. So what is going to be complex implementation is that it requires expertise in security protocols, API management, and compliance. And what about latency issues is that the encryption and security checks can sometimes slow down the data exchange, and potential API vulnerabilities. Poorly secure cloud API can be exploited by attackers. Security relies on third-party cloud services, leading to some potential risk. And some organizations may hesitate to store some sensitive data on the cloud. Okay. So this is all about the drawbacks. But if you go for some in real time, like a developer accessing the resources from a new API may trigger a threat alert. Okay, so too many alerts can cause some alert fatigue, right? So like ignoring some missing or some critical events. Like what is make performance overhead is that like constant monitoring and scanning can introduce the latency or resource overhead on some cloud infrastructure, and this can slightly impact the app or service performance, especially in some large scale systems. And the complex configuration is like often real-time security rules like fine-tuned policies, role-based access, or custom rules can result in either over restriction or some security gaps. And high cost real-time security features like threat reduction, logging, auto remediation can be expensive. In such a cases, we can increase with some data volume, alert frequency, and storage of logs and scans. And next, like over reliance on automation. Relying too much on automated security actions may disrupt the legitimate users, which causes the system downtime and escalate the problems without the human oversight. And data privacy and compliance risks is that security interfaces often process some sensitive data for scanning. If not properly configured, this can violate some data residency laws, expose some sensitive logs or configuration. And steep learning curve tools like AWS Security Hub, Azure Defender, or GCP ACC can be complex for beginners. It requires time and expertise to fully utilize and avoid some misinterpretation. So that's all. So in this particular video, we have discussed about the geotag concept and its application, and followed by how it is used in real time, the code, and then why we are like Google Cloud is using by use of some web annotations, and what are the various uh, use cases for the geotagging, and followed by some cloud security interfaces. So that we have discussed about the what are the various types of cloud security interfaces and where it is used, what are the applications and what are the advantages and what are the disadvantages. I hope you all find it very useful. So we will check out in the next video. So thank you all.